So we will discuss today Aldol condensation. Aldol condensation is a very important reaction for mains and advanced. So first Aldol condensation, when you are going to start here, what are the types of reactants? What are the types of reactants? First we have to know the types of aldehydes and ketones. So generally aldehydes are simple aldehyde C double bond OH and CH3 C double bond OH and CH3 C double bond OCH. So these are the telephatic aldehyde. And what are the cyclic aldehyde? Cyclohexane with C double bond OH and cyclopentane C double bond OH. These are called aromatic aldehydes. And what are the next ones? Aromatic aldehydes. Aromatic aldehyde means benzene C double bond OH. So which of the following molecule will participate in Aldol condensation? So in exam there are this type of questions for mains. First one here, you have to choose that what is that alpha carbon and alpha hydrogen. Now alpha carbon means this is the function group attached. This is the function group attached carbon we call as a function group carbon. This is the function group. Here there is no alpha carbon children. In the second case, if you are taking this is a function group attached carbon we call as a alpha carbon. And here no alpha carbon. Here how many alpha carbons? This is the alpha carbon and this is also alpha carbon. And alpha carbon containing hydrogens. Are called alpha hydrogens. So in this case, there is only one alpha hydrogen. Here also only one alpha hydrogen. Here alpha hydrogen, this is that alpha carbon, but here alpha hydrogen is equal to 0. For Aldol condensation, what is the basic important thing is that minimum 2 alpha hydrides are required. Now what is the basic fundamental equation for alpha? What is the basic equation means? Aldehydes, 2 moles of aldehydes in presence of the base, it will use beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound on heating will get that alpha beta unsaturated carbonyl compound. Now, here what is the first condition? This aldehydes, generally aldehydes and ketones both will participate in that Aldol condensation. Generally aldehydes are more favorable. Here aldehydes are more favorable than ketones. Aldehydes are more favorable than ketones. Now what are the Aldol? So with alpha hydrogen, carbonyl compounds will participate in Aldol condensation. Without alpha hydrogen, carbonyl compound will participate in conjugal reaction. So what is the conjugation? With alpha hydrogen, carbonyl compound will participate in that Aldol condensation. And without alpha hydrogen, carbonyl compound in presence of the base. So here also we have to use the base chiller. Here we will use generally mild base. Mild base is a catalyst, and here we will use a strong base. Strong base means around 50% of the concentration. This one will form Cannizzaro reaction. Now, what are the steps in the Aldol condensation? So what is the first step means? For Aldol required 2 moles of carbonyl compound. Which carbonyl compound? With alpha hydrogen carbonyl compound, either aldehyde or ketone. Now example, what are the examples given here? You can take a CH3, C double bond OH, or CH3, C double bond O, CH3, or you can take a benzene, C double bond O, CH3. Now see children, this carbon, this is the function of C double bond O. The C double bond O containing carbon we call alpha hydrogen. Here also alpha hydrogen. Here also alpha hydrogen. Here children there is no alpha hydrogen. This one is the alpha hydrogen. Now, what is the basic fundamental equation? First step. If you take that mechanism, children, what is that mechanism? Step 1. CH3, C double bond OH in presence of the base. In presence of the base, these all are reversible reactions, children. If you are taking the base, this base with these are the alpha carbon. This alpha carbon hydrogens are little acidic in nature. So this CH2, when you add the base will abstract the proton and it will generate the CH2 minus C double bond OH. So this one is stabilized by resonance. This one, these electrons are moving to this side. Oxygen is more electronegative. Already you have seen same in that chemical bond also. So what you will get children here? This one is stabilized by CH2 double bond C O minus and H. So this one we call enolate ion. This one we call as a enolate ion. So this one is the step 1. So the step 1 is the generation of the enolate ion. Now what is the step 2 children? Step 2, this is the first mole. This is the first mole children. Now we have to first mole. Now we have to take the second mole in the second step. This CH3, C double bond O, H. When you add the enolate ion, CH2 double bond C O minus and H, this electrons will come here and this electrons will come here and this one will generate as a nucleophile. This nucleophile is going to attack carbonyl carbon. This nucleophile is going to attack carbonyl carbon. This one we call as a nucleophilic addition and here CC bond formation will take place. So step 1 is that bond formation. Step 1 is that generation of the enolate ion or generation of the nucleophile. Step 1 is the generation of the nucleophile. Step 2 is the addition of nucleophile. Step 2 is the addition of nucleophile. Addition of nucleophile. So in addition of nucleophile, what will happen children? Here CC bond formation will take place and here what you will get? And here CH3, C, O minus and here H and here CH2 and C double bond OH. So these are also reversible reactions. And here which type of base we are taking here? 10% of the concentration base. The base concentration is that 10%. If you are taking that more concentration, the OH minus is going to attack this carbonyl carbon. So when you are taking the less concentration will take the acidic proton here. Acidic proton. These protons, alpha hydrogens are with the acidic nature. In this case, it will take more concentration will take the nucleophilic addition. So what is that one? Step 1 is the generation of the nucleophile. Step 2 is the addition of nucleophile to carbonyl carbon. Here you will get that CH3, C double bond O and CO minus and this one will act as a conjugate base. This one will act as a conjugate base. This one will act as a conjugate base. This conjugate base will abstract the proton from the water molecule. So what you will get here? So this conjugate step 3 is that step 3 proton abstraction proton abstraction from solvent. In this case, this CH3 C O minus and here H and C double CH2 C double bond OH. This one will attract the proton from H2O. So it will form CH3 here OH and here H and here CH2 and C double bond OH. So this one we call as a beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound. Now if you see this carbon containing the 4 different groups. So this carbon containing here hydrogen is there, here OH is there, here CH. So this carbon we call as a chiral carbon. The carbon will form the chiral center. And next step is that on this and this one we call as an Aldol product. This one we call as an Aldol product. This one we call as an Aldol product. Aldol product on heating. Aldol product on heating we will get that alpha beta unsaturated carbon. Alpha beta unsaturated. Now this is the beta hydroxy compound and when we are taking this beta hydroxy CH3 C here OH and here H and here CH2 and C double bond OH on heating. So here we use the base. So in this case children, so first of all in this case this base will attract the proton here. So it will form as a negative charge and this negative charge will go here and this OH minus eliminate. This one will follow the E1CP mechanism. E1CP mechanism. Here you will get the CH3, CH double bond, CH, C double bond OH. This one we call alpha beta unsaturated carbonyl compound and this one will show the geometrical isomers. Means here you will get the this sign trans product. So here children, this one the elimination will follow the E1CP children. In that E1CP case, this one will form the negative charge and this negative charge will participate here and this OH minus will go by heating. And generally here trans product is the major and in this case chiral center here also will get the 2 products. And here small quick revision. So Aldol condensation means generally 2 moles of Aldol means 2 moles of carbonyl compound with alpha hydrogens. And the first step is the generation of the nucleophile. Second step is the addition of nucleophile to carbonyl compound. And third step is the proton abstraction. And the fourth step is the heating of the Aldol condensation. So what are the steps children? First one I write here. So what is the step 1? Step 1 is the generation of nucleophile and step 2 is the addition of nucleophile to carbonyl compound. In this case, new CC bond will form. Here, new CC bond formation and third one, step 3 is the proton abstraction proton abstraction from the solvent, and step 4 is the elimination. Which elimination is going to be E1CB elimination. E1CB elimination. So these are the 4 steps are very important.